Bitcoin and blockchain are revolutionizing the financial industry by providing a decentralized and secure method for transacting digital assets. The technology employs cryptographic techniques to ensure that transactions are immutable and transparent, making it difficult for unauthorized alterations. As a foundation for cryptocurrencies, Bitcoin relies on blockchain technology to facilitate peer-to-peer transactions without the need for a central authority. A blockchain is a decentralized, immutable chain of blocks that are linked together by cryptographic references, ensuring that each block is a secure and verifiable record of transactions. By utilizing a distributed ledger, blockchains eliminate the need for intermediaries and ensure that data cannot be easily altered once recorded. This architecture is critical to the functionality of cryptocurrencies like Bitcoin, allowing for trustless and transparent financial systems. The structure of a block in a blockchain consists of several key components, including the transaction data, the hash value of the current block, and a reference to the hash of the previous block. This interconnection ensures that any changes to a block would require alterations to subsequent blocks, maintaining the integrity of the entire chain. By storing transaction data securely, each block serves as a permanent record of the economic activities within the network. The transaction data within a block includes information about sender and receiver addresses, the amount transferred, and timestamps, all of which are encrypted for security. Each transaction is verified by network nodes before being added to a block, ensuring accuracy and preventing double spending. This data is essential for the execution of financial transactions and maintaining a transparent record within the blockchain. By employing hash functions such as SH256, blockchain technology ensures that each block is uniquely identifiable and tamper-proof, maintaining the continuity of the chain. Hashing transforms transaction data into a fixed-size string, enabling quick verification and efficient storage. This cryptographic method ensures that even the smallest change in data will result in a significantly different hash, making it a cornerstone of blockchain security. The hash value in blockchain serves as a unique identifier that ensures the integrity of each block by representing its entire contents in a fixed-length string. It is calculated using cryptographic algorithms, and even a minor change in input data will produce a significantly different hash, thus protecting against unauthorized modifications. In Bitcoin, the SHA-256 algorithm is used to generate this hash, providing a secure and efficient mechanism for block validation. The previous block hash is a critical component of each blockchain block, linking it to its predecessor and forming a continuous chain. This reference ensures that any alteration to a block would require recalculating all subsequent hashes, thus maintaining the security and immutability of the blockchain. Such chaining ensures that the entire blockchain remains trustworthy, as tampering with one block would necessitate an impractical amount of computing power to alter the entire chain. In blockchain technology, encryption and hashing are essential for maintaining data security and integrity within the network. Hashing, particularly through algorithms like SH256, provides a way to verify the authenticity and integrity of data without revealing the actual content. Encryption further safeguards sensitive information by converting it into unreadable formats, requiring specific keys for decryption and thus ensuring confidentiality in transactions. The SHA-256 hash function is a cornerstone of Bitcoin's security, transforming input data into a 256-bit signature that is unique to each block. This one-way function ensures that it is computationally infeasible to reverse engineer the original data from the hash, thereby protecting the blockchain from tampering. By producing a fixed-size output, SH256 facilitates efficient data verification and storage, making it integral to the blockchain's operation. Merkle trees are a pivotal structure in blockchain, enabling efficient verification of transactions by organizing them into a binary tree where each leaf node is a hash of a transaction. The tree structure allows for quick and reliable checks of transaction integrity without needing to download the entire block, enhancing the blockchain's scalability and performance. This approach reduces the computational load on nodes, allowing them to verify transactions with minimal resource usage, thus supporting the overall efficiency of the network. Merkle trees use a hierarchical structure comprising multiple levels of hashes to efficiently verify transactions, ensuring data integrity without downloading entire blocks. Each leaf node represents a transaction hash, while parent nodes up to the root aggregate these hashes, providing a single Merkle root for quick validation. This structure allows nodes to verify transaction inclusion with minimal resources, enhancing scalability and performance of the blockchain. Blockchain operates by utilizing a decentralized ledger where blocks are added sequentially, each linked via cryptographic hashes to maintain integrity. Blocks store transaction data and reference previous ones, ensuring any tampering requires recalculating subsequent hashes, a process secured by consensus mechanisms. This decentralized structure enables trustless transactions and prevents data alterations, forming the foundation for cryptocurrencies like Bitcoin. Chaining of blocks is a mechanism where each block in the blockchain contains a hash of the previous block, ensuring a chronological order and integrity. This hash linkage acts as a security measure, making it computationally difficult to alter any block without affecting subsequent blocks. By maintaining a continuous chain of blocks, the blockchain ensures transparency and immutability across the decentralized network. Hash linkage in blockchain involves each block containing a reference hash to its predecessor, forming a secure and interconnected chain. This linkage ensures that any alteration in a block would necessitate changes in all subsequent blocks, preserving the chain's integrity. By relying on cryptographic hash functions like M256, blockchain maintains a tamper-proof and verifiable record of transactions. Consensus mechanisms in blockchain are protocols ensuring agreement among distributed nodes on the validity of transactions and blocks. Proof of work is a common mechanism where miners solve complex mathematical problems to validate new blocks, ensuring security and preventing fraud. By requiring consensus, these mechanisms maintain the decentralization and trustworthiness of the blockchain network. Proof of work is a consensus mechanism where miners compete to solve complex mathematical puzzles, ensuring block validation in the blockchain. It requires significant computational resources, making it difficult for malicious actors to alter previous blocks. By utilizing this method, the blockchain maintains decentralization and security through a distributed network of nodes. Hash rate refers to the computational power used by miners to solve the puzzles required for block validation in the proof-of-work system. It is measured in hashes per second, indicating how many calculations a miner can perform in a given time. A higher hash rate increases the likelihood of successfully mining a block and receiving a block reward. Block mining involves using computational power to solve cryptographic puzzles, thus validating transactions and adding new blocks to the blockchain. Miners compete to find a valid hash that meets the network's current difficulty requirements, earning a block reward for their efforts. This process is critical for maintaining the blockchain's integrity and generating new Bitcoin units. Difficulty adjustment is a mechanism in the proof-of-work system that ensures a consistent block time by dynamically changing the complexity of mining puzzles. It occurs approximately every 2016 blocks to maintain an average 10-minute block interval in Bitcoin. This adjustment reacts to the total network hash rate, increasing difficulty when more miners participate and decreasing it when fewer are involved. The nonce value is a random number used in block headers that miners alter to find a valid hash under the proof of work consensus. By changing the nonce, miners can generate different hash outputs until one meets the network's difficulty target. This trial and error process is fundamental for ensuring the security and immutability of the blockchain. Block size and time are key factors in maintaining the consistency and functionality of the Bitcoin blockchain. The block size limits the data capacity of each block, affecting the number of transactions processed and influencing transaction fees and network speed. The block time is a critical component in ensuring that new blocks are added at regular intervals, which is essential for maintaining the network's security and efficiency. The block size in Bitcoin refers to the maximum amount of data that a block can contain, which is currently set to 1 megabyte. This limitation is intended to maintain a balance between transaction throughput and the decentralized nature of the network, ensuring that nodes can operate efficiently. The block size plays a critical role in influencing the number of transactions processed per block, directly impacting network scalability and transaction fees. The block time in Bitcoin is designed to be approximately 10 minutes, which is the average time it takes for a new block to be added to the blockchain. This interval is maintained through an automatic difficulty adjustment mechanism, which regulates the complexity of the cryptographic puzzles miners must solve. Consistent block times help maintain a predictable flow of new Bitcoins into circulation and ensure the network's stability and security. A Bitcoin transaction involves sending digital currency from one user to another over the blockchain network, where it undergoes verification by network nodes. Once verified, the transaction is grouped with others into a block and added to the blockchain through mining. This process ensures that transactions are secure, preventing issues like double spending and maintaining a transparent record of ownership. The transaction process in Bitcoin involves several steps, starting with the initiation of a transaction by a user, who signs it using their private key. The transaction is then broadcasted to the network, where nodes verify its validity by checking digital signatures and ensuring sufficient balance. Finally, validated transactions are collected into a block by miners, who compete to add the block to the blockchain, ensuring network integrity and consensus. In the Bitcoin network, transaction verification ensures that each transaction is valid and complies with network rules before it is included in a block. Nodes verify transactions by checking the digital signatures and ensuring there is no double spending, maintaining the integrity of the blockchain. This step is crucial to prevent fraudulent activities and ensure that all transactions are authentic and legitimate. Once a transaction is verified, it is stored in a block, which involves being bundled with other transactions and recorded on the blockchain. The block must include not only the transaction data, but also a hash of the previous block to ensure continuity and security. This storage process is fundamental to maintaining a permanent, immutable record of all transactions on the Bitcoin blockchain. Bitcoin transactions utilize an input and output system to manage the transfer of funds between addresses. Each transaction has one or more inputs representing the source of the funds, and one or more outputs indicating the destination address and the amount to be transferred. This system allows for precise control over Bitcoin transfers, ensuring that funds are accurately and securely sent from sender to receiver within the network. Address transfer in Bitcoin involves moving funds between cryptographic addresses,